On recharged off a break, so that's good. Use that energy in a positive way towards stuff like this. Okay. All right, so we got Unit 3, Lesson 6. We're going to do 6 and 7 in the same video. First off, it's laws of logarithms. Okay, so the point is, on the standard is, how do the logarithms work in terms of their laws? Okay, they have laws just like exponents have laws, which makes sense because logs are inverse of exponents. They have similar laws when it comes to that. Okay. So evaluate the following. So we did log 2 of 16 plus log 2 of 8. And then what's log 2 of 16 times 8? And so if you go ahead and calculate those, and it looks like I do have my calculator, so I can try that real quick. So if I do log, it was log of 2, right? No, 16. Log, yeah, log based. Okay, so I got to do this a little bit different here. So yeah, I just have to do the change of base of mine. Some of you guys' calculator does that for you. Okay, and then that was to be plus. If yours does it, you can just do it on your own. It's fine. Okay, so that's the first calculation. It's 7. Okay, so all I did there, if you're lost on what I punched in, is that I had to change a base because the base is 2. So I did log 16 over log 2 plus log 8 over log 2, and I got 7. And now we're going to do log of 16 times 8 over log 2. Okay, so that's not a coincidence. We got 7 and 7. Okay, so signifying they're equivalent. Okay, and that's going to be your first law. That's the product law. So if they are multiplied, you can separate them as addition. If they're addition, you can put them together as multiply. You can go vice versa on whichever helps you with whatever you're solving. Okay, it's more of a tool. Just like when you're solving something, you have to divide, right? Sometimes you don't. Sometimes you need the product rule, sometimes you don't. Okay, so it's the product law. Let's look at this one as well. We'll just do it one more time. So let's do 27. So I got log of 27 over log 3. And then plus log 3 of 3, which we know is 1, but we'll plug that in still, just to be consistent. I know log 3 over 3, that's tedious, I get it, but we're just putting it there to be consistent. So 4. Okay, and now if I do log 27 times 3, divided by log 3, you get 4 as well. Yep. Can you add the exponent? Uh-huh. Yeah, 2 to the power 4 and 2 to the power 3. Yeah, 4 plus 3 is 7. Yeah. Yeah. Because you're putting it together, you're getting here essentially. So what he's asking is, he knows that this right here is 2 to the 4th. This is 2 cubed. 4 plus 3 is 7. That's exactly right. They're giving you basics here just for showing you the rule. But let me show you a little further. See how it's written like this? This would be 2 to the 4th and 2 to the 3. And what do you do with the exponent rules there? You add them. So it's exactly what he's saying. Okay? So this product law obviously is addition, which makes sense because the exponents, you add them anyways.
Can you only do it if you have the same base?
Same, oh, like these? Yes, absolutely, yep. This is the important part. Okay? If we'll be able to do it still if they're not, these aren't bases of 2's. They're showing you a nice smooth one that gives a nice whole answer, but sometimes the answers aren't whole. So you can still do the product law. If like this was like a 9, we could still do 16 times 9 and evaluate that.
But you still have to have a 2 on.
Right, these bases have to be the same.
Oh, okay.
Yes. Okay, good. Anything else? This is just the beginning, okay? We're investigating here. So that's what the product law looks like. So comment that they're the same answer. They're the same answer, no problem. Okay, and then obviously, not obviously, but think about product laws, addition, quotient law, subtraction. Okay, that's makes sense, right? We're used to that relationship by now in our math career. Okay, so this one here, log 16 minus log base 2 of 16 minus log base 2 of 8. I'm just going to go ahead, and I won't punch in the calculator, save time here, but we got 2 to the 4th and a 2 cubed, so you can see it's going to be 1. Right? 2 to the 4th over 2 cubed, so you're going to get a 2 to the 1, sorry. 2 to the 1, so you should get just 2. Okay? Let's make sure of that here. 2 to the 1, or is it 2? No, I was right. It is 1. It's the exponents. My bad. It is the 1, because it's 4 minus 3. Because right here, 2, 4, 2, 3 is a 2 left. Log 2 of 2 is 1. So we know that. Okay. All right. This one here, just for more practice, we're going to have log 3 of 3 cubed minus log 3 of 3. 3 minus 1 is 2. Remember, those cancel. That cancels. So you get 2. If you do it here, you're going to get log 3 cubed over 3 to the 1, which you're going to get log 3 of 3 squared, which is 2. Because this cancels. All right, they are the same answers again. Just put same's fine. So essentially, we've just gone over what the product and quotient law is. The product law is the addition to multiplication. The quotient law is subtraction to division. Okay? So remember, you can make it a subtraction of 2 logs or a division of 1 log with the same base. Product was you can make it a addition of 2 logs with the same base or a product with 1 log. Okay? And so here is the summary of those rules. Okay, so this is what you want to make sure to note. Okay, so then it says, for example 1, evaluate the following, use the product law or quotient law. So what you have to get in the rhythm of doing is, I see a minus, they have the same bases, so I'm thinking quotient law, okay, division. So what I'm going to do is, I'm going to go ahead and write this essentially as a quotient. Log 2 of 12 over 3. Now that's helpful because we know what 12 over 3 is. What's 12 over 3? 4. Yeah, so we're going to write it log 2 of 4. And so then everybody in this room knows 2 to what power is 4? 2, so your answer is 2. Okay? If you want to take this a step further, it's fine. You could write like this if you want to see it better. 2 squared, those cancel. 2 is your answer. That's fine too. Okay? Okay, a lot of you guys aren't dialed in right now. You need to reel it back. Okay, come back from break right now. This is where things get complicated. We're in lesson 6 and we're doing 7. This is a big chunk of what you're going to be asked to do on your assessment. So if you can't be doing these simple quotient and product laws, it's going to be very difficult for you. Okay, so a lot of you right now, you're not here. Okay, so get here. Okay, so log 6(9) plus log 6(8) minus log 6(2). So addition and subtraction. So it's a product with a quotient. Okay, so you can still write these all as 1. Okay, you can write it like this. Log 6 of 6 times 8 over 2. Oh, is it 9? Oh, 9, yeah, sorry. The base is 6, thank you. I'm not here, apparently. 9 times 8, there we go. 9 times 8 over 2. Okay, that gets you 72 over 2, which is 36. We know that 6 to what power is 36? 2. Okay, if you need to see it the whole way would be log 6 of 6 squared. Those cancel, answer is 2. just doing examples for this section, okay? That's all. We're not doing any long investigations, so ask questions, okay? Whatever you need. All right. So use the law of logarithms to write log x of 10 plus log x of 75 minus log x of 2 plus log x of 3 as a single logarithm. So practicing writing this is one logarithm. Again, the key point, and this is what Leah kind of asked earlier, that those have to be the same for us to do anything like this. All those bases being x's, that's what we really have to make sure we're on the same page with. Okay? So addition here, so product. So let's call that log x of 750. And then it's going to be minus this product, which 2 times 3 is 6. So it's going to be 750 over 6. 750 divided by 6 can be done. Log x of 125. That's a single logarithm. Yep. It's for this where it says single logarithm, I would write it as a single number if you can. I don't know if I would say if I'd get it wrong. I just don't know why you would want to leave it in a fraction form, I guess is my question. Okay, now it says evaluate if x equals 5, so then we plug a 5 in. Well, 5 to what power is 125? 3, good. So we know it would be 5 cubed, so that cancels, you get 3. Remember, 5 cubed is 125, if you're wondering where I got that. So I'm talking about lessons 2 and 3. If you've done those practices, your exponents should be solid. If you haven't, you're still swimming with exponents, logs are going to be very difficult. Okay, again, let's do example 3. I'm going to pause the video. I'm going to let you try it, and just like the one we just did. Go ahead and try it all. All right, so let's take a look here. So, yep, this one's going to be a negative. It's right there, 2 times 3, so that's log b of 6 minus and minus. So if those are minus and minus, they're going to be division. Okay, so the thing on this one here, you can pull like a, if you're confused what happens here, you could do this to help yourself see. You could pull a minus out. If you pull a minus out, that just helps you see that it's really, you're putting them both in the bottom. Okay, so that's what that can help you with. Okay, so 6 times 8 is 48. So then it's going to be log base b of 6 minus log base b of 48. And so now you can see it's 6 over 48, which is 1/8. Okay. Now, that's all as you can go for part A because we don't know what b is. And now they tell us that b is 2. So we know now it's log 2 of 1 over 8 we should know is 2 to the negative 3. Okay? That b's bothering me. It's really bad. Okay, that's not any better, but I tried. Okay, so then log base 2 of 2, you should get negative 3 for your final solution there. 48, 6 times 8. Right, because see how these are both minuses? That means they're both on the bottom. So that means they're essentially multiplied on the bottom is what you're dividing by. And so I was explaining is where that looks kind of tricky, you can pull a minus out to make it a group. And so you can see I'm dividing this group because they both have a negative in common. Okay? Sure, what's your different way? 1, yeah. Yeah, and then you divide again, right? But the point is they're both being divided, so they're both in the bottom. But yeah, so Cash said he did a different way. He got 6, he divided by 6, which is fine. And he got 1, and then he divided by 8. He got 1/8. That works too. Okay, because you're doing in order. Okay, both ways work. I think the biggest thing you need to understand is that this means division, this means division, so they're both underneath. Okay, they're both underneath. That's the big part. Okay, any questions? Okay, negative 3, everybody okay with that? All right, let's keep on going through some examples here. The expression of log base 2 of x plus log base 2 of 2x minus log base 2 of x squared minus log base 2 of y is equivalent to what? Okay, so let's see what it is here. So we got, what's this going to be? 2x squared. Okay, and then I have minus and a minus, so what I just tell you to do in that case? They're both going to be on the bottom. So now we can simplify. You can see that this x squared is gone. And so now you have log 2 of 2 over y. Now, you're trying to figure out which one of these that is. Well, why? See that 2? That 2 kind of stands out to me because why? Why does that 2 stand out? Because what's my base? 2. It's a 2. So now I'm thinking, and this is where I'm talking about, you have to really be flexible with what you can do. Let's unwrap this again. I know we just put it as 1, but now let's unwrap this to be like that. Well, what's log 2 of 2? 1. So D. What happened to the x squareds? But it's an x squared. You have 2 of them and 1 of them, so your x squareds cancel, so now it's 2 over 1. Be no different if it was 2 times 10 over 10. The 10s would cancel. Yeah, that's normal, because it's a product. Not addition or subtraction, it's a product. Okay? Okay, that's fine. I mean, I can make sure it wasn't lucky, but that's fine. We can look at it in a little bit, okay? Okay. All right, so 5. I'll keep the page here. Determine the value of 3 log 2p minus 3 log base 2q if p over q equals 8. Okay, so a little bit tricky here. Really making you do some work here. What I would suggest doing on this one is we want to get in this situation where we have a p over q. This is kind of a diploma type question because you're going to be like, well, I don't see p over q. Well, exactly. You need to get to a point where you can get p over q. But we do see a minus sign, so that makes things a little bit easier, right? So then what's the next thing you look at that bothers you there? What's that? I'd say the 3. The 3's in front are now kind of like conflicting for me. So what I'm going to do is I'm going to pull the 3 out. Because there's 3 in both of them. That's a common factor. Now, in my brackets here, I have a nice smooth log base 2 of p minus log base 2 of q. I can make that one logarithm. Okay? So now I'll come over here. It's going to be 3 log p over q. And that's base 2. And then we know that p over q is 8, and so now we can finish. Okay. So don't worry about the 3 right now, but we know that log 2 8 is going to be what? 3, right? Because 2 cubed is 8, right? So we know that's 3, and so then your answer is going to be 3 times 3 for 9. So number 5's answer will be 9. Okay, again, this last part here, if you got lost, 8 is 2 cubed, so it's 3 log 2 of 2 cubed. Those cancel. That means it's just 3. 3 times 3 is the 9. All right, last little piece here for this one. Lesson 7's even shorter. I think I might make 2 videos, though. Okay. Investigating the power law. So by writing 2 log x as log x plus log x, show that 2 log x equals log x squared. So this is the power law. You've kind of seen this quite a bit. And this one's really helpful when those 3's are in the way, or you have an exponent in your logs that you can kind of move them to make things not have exponents where you don't want them. So by writing 2 log x as log x plus log x, right? Because this is like common terms. Just like, x plus x is 2x, right? So log x plus log x is 2 log x. Show that 2 log x equals log x squared. Okay? Well, if it's log x squared, how would you write that? So for example, we know that 2 log x equals this right here. what they have. But then we also know that this right here, log x plus log x, how can I write that? Right, that's log x squared, because it's x times x, product law. Okay, so let me say that one more time. 2 log x equals log x plus log x. 2 log x also equals log x squared by our product law. Okay, because this, I'll even write this even a little bit clearer, x times x, right? Addition means multiplication. Simply though, guys, I want you to understand that whenever you have, let's just say a y cubed, you can bring that in front with logarithms. So what we need to understand is log y cubed equals 3 log y. Okay, that's the operation that we can do with our exponents. That's the power rule that I'm kind of explaining to you right now. Just want to give you this short Cliff Notes version. The exponents can be dropped in front, or if they're in front, they can be pushed back up into the number. Okay, so if I gave you a 5 log z, I could also write that as log z to the 5th. Just that nice little move there. Okay, to prove that 3 log 2a equals log 2a cubed. Okay, so we know that 3 log 2a is 3 of them. And if it's 3 of them, then we know that it can also be written as a times a, which is log 2a cubed. So we're just proving that Cliff Notes that I was just telling you. You can just, what do you mean by cancel out?
Well, like, because you know that's those are, there's 3 of them there, and there's 3 of them there, so we can just say,
Sure, I mean, but I just don't like the word cancel because that means you're like eliminating something. You can write the 3 as a one thing with a 3, that's fine. But I'm just making sure your terminology matches up, okay? But yes, you can condense it. Is that better? Okay. Write an expression equivalent to a log b of c. So what they're saying is, now prove that you understand what's happening. So what would you write? Log b of c to the a. Good. Log b of c to the a. Like that. Very good, very good. Okay, so we have proven the power law. So those are the main laws, guys. Product law, quotient law, power law. Okay? That's the main focus here. So let's go ahead and do these. Now, obviously the power law you want to highlight, go ahead. That's important. Okay? Well, let's get to it. Without using a calculator, evaluate the following. Okay? Don't get calculator dependent. Okay? There'll be non-calculator sections. Okay? So keep that in mind. Okay? So we have log 4 16. First thing that's bothering me is this 12, so I'm going to put the 12 in front. And I'll write 16 as a 4 squared. Okay? So then I know that cancels. It's going to be 12 times 2. 24 is my solution. Okay. Now obviously, 10 to the 21st power is pretty insane, right? That's going to be 21 zeros. So we're not going to want to do anything like that. That's kind of crazy, right? But we do know that this, if there's nothing here that's a base of 10, we like that because that means log 10 of 10 is 1. But we just got to get this down. So just write it down. Okay, 21. Okay, any questions? Last example here for lesson 6 coming. Give you a short break after. Nothing? All right. Okay, so this one right here, we know, simplify the following. So we know that log 6 of 6 just cancels. The n comes in front, so the answer is n. And then we know this one is also n. And so that's just kind of giving you 2 examples that prove the power law. So this drops in front, that cancels. This cancels, this comes down. There's your two answers there for the identities. Okay, all right, give you about 2 minutes.